Calculate the length of the sides of triangle PQR given the vertices of PQR. Now, with coordinate geometry, it's strongly advisable in every single problem that you get, you always draw a diagram. It doesn't have to be 100% accurate. It needs to be accurate enough for you to get an idea what is required from the problem. So the first thing we're going to do is plot these points. And we're required to find the lengths of the sides of triangle PQR in order to show whether the triangle is right angled or not. This is not the only way to go about it. This exercise is primarily on working with lengths of line segments, but we're going to approach this problem with gradients as well, right? So we can determine the lengths of the sides of triangle PQR, and then if Pythagoras' theorem applies, then PQR will be right angled. Now, the reason why you're required, it's a good idea to draw a diagram, is we can clearly see that the only possible right angle here is going to be at angle R, right? The way that the diagram has been sketched by plotting those points. So it just saves a hell of a lot of time knowing what you're looking for. So if you just went to determine the length of the sides, you would then have to go through a whole bunch of permutations to determine whether the triangle is right angled. By drawing the diagram, it saves you a lot of time. Using Pythagoras theorem, we're going to determine PQ squared. Then we're going to determine PR squared and QR squared. We're going to sum PR squared and QR squared. And if the sum of PR squared and QR squared equals PQ squared, then we know that PQR is right angled because it obeys Pythagoras' theorem. So we're going to do that first, and then the second approach will be using our knowledge of perpendicular lines and gradients. So we'll start with the lengths for now. So PQ, the distance formula is given by the square root of x2 minus x1 all squared plus y2 minus y1 all squared. So x2 minus x1 will be 6 minus minus 4. So square root of 6 plus 4 all squared plus y2 minus y1, 1 minus 6 all squared. That equals the square root of 6 plus 4 is 10 squared is 100. 1 minus 6 is minus 5. Minus 5 all squared is 25. So PQ equals the square root of 125. We're not going to simplify this. This does equal 5 root 5. But we're not going to simplify that because we are looking to show that PQ squared equals PR squared plus QR squared. In fact, we could just as easily just square this immediately. So if PQ is root 125 and PQ squared equals 125, because we can be using Pythagoras' theorem, or at least applying it, it's probably a good idea to just express it like that. And we'll do the same for PR and QR. PR equals the square root of x2 minus x1 all squared. So we'll have 2 minus minus 4, 2 plus 4 all squared plus y2 minus y1, 9 minus 6 all squared. It's the square root of 2 plus 4 is 6, 6 squared is 36. 9 minus 6 is 3, 3 squared is 9. So we have the square root of 36 plus 9, which is the square root of 45. That's PR. Again, we can just write this as PR squared equals 45. And finally, QR equals the square root of 2 minus 6 all squared plus 9 minus 1 all squared. That's the square root of 2 minus 6 is minus 4. Minus 4 squared equals 16. Plus 9 minus 1 is 8. 8 squared is 64. So we have square root of 16 plus 64, which is the square root of 80. And therefore QR squared equals 80. Now, if PQR is a right angle triangle at R, then PQ squared will equal PR squared plus QR squared. So we are simply going to just write down PR squared plus QR squared equals 45 plus 80, which equals 125. And 125 is the length of PQ squared. So because PQ squared equals PR squared plus QR squared, therefore triangle PQR is right angled at R. Okay, now the second approach to showing that PQR is right angled is to show that PR is perpendicular to QR. And to do that, we're going to work with the gradients of PR and QR. So the gradient of PR is y2 minus y1 over x2 minus x1. So we'll have 9 minus 6 over 2 minus minus 4, 2 plus 4. That gives us 3 over 6, which is a half. Likewise, the gradient of QR, y2 minus y1 over x2 minus x1. So we will have 9 minus 1 over 2 minus 6, and that equals 8 over minus 4. The gradient of QR is negative 2. Now, for perpendicular lines, if two lines are perpendicular to each other, then the product of their gradients is negative 1. So the gradient of PR times the gradient of QR equals a half times minus 2, which equals negative 1. So therefore, PR is perpendicular to QR. Question 2. Given P 1, 6, Q minus 2, 1, and R 3 minus 2, show the triangle PQR is a right-angled isosceles triangle and calculate the area of this triangle. Okay, again, the first thing we're going to do is always plot the points, draw a diagram, so we can get an idea as to how to tackle the problem. So now that we've sketched a diagram, it should be clear to see that if we're going to show that triangle PQR is right angled, the only angle that possibly looks like it's right angled is angle Q from the diagram. Again, this saves a lot of time in an exam. So to show the triangle PQR is right angled, we have two options. We can either apply Pythagoras' theorem, and that's working with lengths. We can do that, but it may be easier to, since we have obviously the coordinates of the vertices of the triangle, is to show that PQ is perpendicular to QR. And again, we're going to just show that the gradient of PQ times the gradient of QR equals negative 1. This is the criteria for perpendicular lines. So you can apply Pythagoras' theorem, but the question will probably not tell you what method to use. Right? It'll just say show that the triangle is right angled. You'll then choose whichever method you're more comfortable with. We're going to work with the gradients, since we've already shown how to apply Pythagoras' theorem in the previous question. So gradient PQ equals y2 minus y1 over x2 minus x1. So 1 minus 6 over minus 2 minus 1. That's minus 5 over minus 3, which is 5 over 3. Gradient QR equals minus 2 minus 1 over 3 minus minus 2, so 3 plus 2. That's going to be minus 3 over 5. Now the gradient of PQ times the gradient of QR equals 5 over 3 times minus 3 over 5, which equals negative 1, and therefore we can say that PQ is perpendicular to QR, and therefore PQR is right angled. We also required We need to show that it's an isosceles triangle. So that's the next step. So we'll call this part B. And to show that it's isosceles, from our diagram, you can clearly see that PR is the longer side. So we're going to determine the length of PQ and the length of QR and show that they are equal. So PQ is the square root of x2 minus x1 all squared. So minus 2 minus 1 all squared plus y2 minus y1, 1 minus 6 all squared. PQ is the square root of minus 2 minus 1 is minus 3 all squared is 9. 1 minus 6 is minus 5 all squared is 25. So PQ equals the square root of 34. And likewise, QR is the square root of x2 minus x1 all squared. So 3 minus minus 2, 3 plus 2 all squared plus minus 2 minus 1, minus 2 minus 1 all squared. Equals the square root of 3 plus 2 is 5, 5 squared is 25. Minus 2 minus 1 is minus 3 all squared is 9. Therefore, QR equals the square root of 34. Therefore, PQ equals QR, both equal the square root of 34, and therefore PQR is an isosceles triangle. So we've proven part B. And part A, we now need to calculate the area of the triangle. The area of triangle PQR in a right angle triangle is given by a half base times height. So the base and the height are interchangeable. It doesn't matter which one you call which. The fact is the base and the height are perpendicular to each other. So this will be the area is a half PQ times QR. PQ we just determined is the square root of 34, and so is the length of QR. It's an isosceles triangle, so the area of triangle PQR equals 17 square units. Distance between 2 points P, A minus 1 and Q minus 5A is 4 root 5. Find the two possible values of A. Okay, now because we don't know what A is, we can't plot the point, so the grid's not going to be helpful here. We are just going to apply the distance formula. The distance between P and Q is 4 root 5. In other words, we're going to establish an expression that represents the distance between P and Q, and then equate that to 4 root 5. So PQ equals the square root of x2 minus x1 all squared, so minus 5 minus A all squared plus y2 minus y1 all squared, A minus minus 1, A plus 1 all squared. And PQ equals 4 root 5. So 4 root 5 equals the square root of, we're just going to multiply this all out, A squared plus 10A plus 25 plus A squared plus 2A plus 1. 4 root 5 is root 80, and that equals the square root of, just cleaning this up, 2A squared plus 12A plus 26. Then we square both sides, so 80 equals 2A squared plus 12A plus 26. 2A squared plus 12A plus 26 minus 80 is minus 54 equals 0. Simplifying that, A squared plus 6A minus 27 equals 0. That factorizes A minus 3 times A plus 9. So A equals 3 or A equals minus 9. So the 2 points, if P is the point 3 minus 1, then Q is the point minus 5, 3. Or if P is the point minus 9 minus 1, then Q is the point minus 5 minus 9. So if P and Q are these coordinates, then the length of the line segment PQ in each case will be 4 root 5, and it's a good idea to always check your work. So in the first case, PQ is the square root of minus 5 minus 3 all squared plus 3 minus minus 1, 3 plus 1 all squared. That's the square root of minus 8 all squared is 64. All squared is 16. So PQ equals the square root of 80, which in simplest form is 4 root 5, so that checks out. And likewise, in the second case, PQ equals the square root of minus 5 minus minus 9, so minus 5 plus 9 all squared plus minus 9 minus minus 1 minus 9 plus 1 all squared. That's the square root of minus 5 plus 9 is 4, 4 squared equals 16, minus 9 plus 1 is minus 8 all squared is 64, and again we get PQ equals the square root of 80, which is 4 root 5, so our solution is correct. Question 4 is very similar to question 3, so I'm going to leave it for you to do as an exercise. Point minus 2 minus 3 is the midpoint of the line segment joining P minus 6 minus 5 in QAB. Find the value of A and the value of B. Okay, so the point minus 2 minus 3, we'll just call that point R. R is the midpoint of PQ. So the first thing we're going to do is find an expression for the midpoint of PQ. Now, the midpoint of a line segment is half the sum of the x-coordinates for the x-coordinate of the midpoint and half the sum of the y-coordinates for the y-coordinate of the midpoint. So in other words, it will be x2, the midpoint of PQ is x2 plus x1 over 2, y2 plus y1 over 2, and always enclose it in brackets because we are talking about a point here. So we will have a minus 6 over 2, that's the x-coordinate of the midpoint of PQ, and b minus 5 over 2 is the y-coordinate of the midpoint of PQ. Now, since the midpoint of PQ is the point R, that means that the x-coordinate of PQ, a minus 6 over 2, must equal minus 2, and the y-coordinate of the midpoint of PQ, b minus 5 over 2, must equal minus 3. So all we do now is equate these expressions. So a minus 6 over 2 equals minus 2, a minus 6 equals minus 4, a equals 2, and likewise b minus 5 over 2 equals minus 3, b minus 5 equals minus 6, b equals minus 1. So Q, in other words, is the point 2 minus 1. As always, it's a very good idea to check your work. So we're going to find the midpoint of PQ. Which is x2 plus x1 over 2. So it's going to be 2 minus 6 over 2. And y2 plus y1 over 2 minus 1 minus 5 over 2. Minus 4 over 2 is minus 2. And minus 6 over 2 is minus 3. And surprise, surprise, we get the coordinates of R. Three of the vertices of a parallelogram ABCD are A minus 7, 3, B minus 3, minus 11, and C 3, minus 5. Find the midpoint of AC, find the coordinates of D, and then find the length of the diagonals AC and BD. Okay, again, we are going to plot these points first before we start. So the midpoint of AC is x2 plus x1 over 2, y2 plus y1 over 2. So the midpoint of AC will be 3 minus 7 over 2 and minus 5 plus 3 over 2. That's going to be minus 4 over 2. It's minus 2, and then minus 2 over 2 is minus 1. So that's the midpoint of AC. Now they tell us that ABCD is a parallelogram. Okay, so now the fact that ABCD is a parallelogram, there's a lot of information we can actually get from this. To find the coordinates of D, the best method to use is the midpoint of each diagonal. That's the quickest and easiest way to find the coordinates of one of the vertices of a parallelogram. So the midpoint of AD, we'll call that M, is the same point as the midpoint of BD. So we know the coordinates of A and C and B, and we're trying to find the coordinates of D. So the midpoint of AC is the same point as the midpoint of BD. So the midpoint of AC is minus 2 minus 1, and the midpoint of BD is x minus 3 over 2, y minus 11 over 2. So we know that x minus 3 over 2 must equal negative 2. And likewise, y minus 11 over 2 must equal negative 1. So x minus 3 over 2 equals minus 2. X minus 3 equals minus 4. X is negative 1. And y minus 11 over 2 equals minus 1. Y minus 11 equals minus 2. Y equals 9. So D is therefore the point minus 1, 9. Now, from our sketch graph, we can see that D is in fact minus 1, 9. That's because it was drawn accurately. But in an exam, you won't have the time to draw it as accurately as that, but you'd get a rough idea where D lies, and D lies in the second quadrant. Finally, find the length of the diagonals of AC and BD. So AC equals the square root of x2 minus x1 all squared, 3 minus minus 7, so 3 plus 7 all squared, plus y2 minus y1 all squared, minus 5 minus 3 all squared. That equals the square root of 10 squared is 100, and minus 8 all squared is 64. So AC equals the square root of 164, which in simplest form is 2 root 41. Likewise, BD is the square root of, let's write the points down, minus 3 minus 11 and minus 1, 9. So BD is the square root of x2 minus x1 minus 1 minus minus 3 minus 1 plus 3 all squared, plus 9 minus minus 11, 9 plus 11 all squared equals the square root of 2 squared is 4 and 20 squared is 400. So BD equals the square root of 404. In simplest form, BD equals 2 root 101. Question 7. The point PK2K is equidistant from the point A 811 and B 112. Okay, so what that means is that P could be somewhere there, it could be here, it could be there. It's basically on the locus of points. We haven't done locus. We don't need to know that. But what it basically means is that P is just as far away from A as it is from B. In other words, if we were to put P up here or maybe over there or wherever, it's on a locus of points on a line such that P is just as far away from B as it is from A. All that means is that PB equals PA. So the square root, we're working with PB now. PB is the square root of 1 minus k all squared plus 12 minus 2k all squared. And PA is going to be 8 minus k all squared, the square root of 8 minus k all squared, plus 11 minus 2k all squared. And because we have square roots on both sides, we're just going to drop those square root brackets and at the same time multiply everything out underneath those square root brackets. 1 minus k all squared is 1 minus 2k plus k squared, plus 12 minus 2k all squared is 144, minus 24 minus 24 is minus 48k, plus minus 2k all squared is 4k squared, and that equals 8 minus k all squared is 64 minus 16k plus k squared, plus 11 minus 2k all squared is 121 minus 44k plus 4k squared. We can cancel the 4k squared terms. We can cancel the k squared terms as well. Cleaning up the left will give us minus 50k plus 145, and that equals minus 60k plus 185. And solving for k gives us 10k equals 40, and then 4k equals 4. So P is therefore the 0.48. So we could then plot that. That's where P would lie. And then P is equidistant from A and from B, forming that isosceles triangle. We're given triangle ABC with vertices A, B, and C as given. We're required to show the triangle ABC is isosceles and find the area of this triangle. The first thing you're going to do is plot the points. Now from the diagram, it's not immediately obvious which two sides are likely to be equal. It looks to me like it's AB and BC. AC does look slightly longer. However, if you haven't drawn an accurate diagram, it's not going to be as obvious. So in that case, you would just find the lengths of AB, BC, and AC, and then just see which two are equal to each other. So the fact that I've drawn this pretty accurately, we are going to find the length of AB and the length of BC. So AB will be the square root of 3 plus 6 all squared plus 5 minus 3 all squared. That's the square root of 9 squared is 81 plus 2 squared is 4. So AB equals the square root of 85. We don't have to put this in simplest form because all we're trying to do is find the length of two sides of the triangle and show that they're equal. And then BC is the square root of 1 minus 3 all squared plus minus 4 minus 5 all squared. That equals the square root of minus 2 all squared is 4 plus minus 9 all squared is 81. So BC equals the square root of 85. Therefore, AB equals BC. Both equal the square root of 85. Therefore, triangle ABC is isosceles. Then we want to find the area of the triangle. So the fact that this is an isosceles triangle, the easiest thing to do, unless you know the area rule, you can apply the area rule, but that entails you need to find the value of, let's just call angle B theta. You would need to find angle theta. To do that, you would first have to find the length of AC using the distance formula. Once you've got all three sides of triangle ABC. You can then apply the cosine rule to find angle theta. From that, you can use the area rule. That is quite a long-winded, drawn-out way of determining the area of the triangle. The easiest thing to do is to drop a perpendicular from B to AC. You can call that point there D. We can do that because ABC is a isosceles triangle. So triangle ABD is congruent to triangle BDC. To find the area of triangle ABC, we need to know the length of AC. So we are going to have to use the distance formula in any case to find the length of AC. BD is the height of the triangle. You therefore need to find the coordinates of D first, which is the midpoint of AC. We know that because we dropped a perpendicular from B to AC such that triangle ABD is equal to triangle BDC. So D would definitely be the midpoint of AC. So you can go about this in either of those two ways. You can either find, you are going to have to find the length of AC in any case, regardless of which approach you choose to use. From there, you can find the angle theta using the cosine rule. Once you've got that, you can use the area rule to find the area of triangle ABC. This may be the quicker way to go about doing it. Alternatively, you drop that perpendicular from B to AC to point D. We know the length of AC because we would have worked it out already using the distance formula. And then to find the length of BD, we first have to find the coordinates of D using the midpoint of AC. Once we have the coordinates of D, we've got the coordinates of B, we can use the distance formula again to find the length of BD, and then we can use half base times height, because we will have the base being AC and the height BD. So we'll start with the first approach. First, we are going to find the length of AC using the distance formula. So it'll be the square root of 1 minus minus 6 all squared. So 1 plus 6 all squared plus minus 4 minus 3 all squared. That's the square root of 7 squared is 49 plus minus 7 all squared is 49. So AC equals the square root of 98, which in simplest form is 7 root 2. We can now use the cosine rule to find theta. So AC squared equals AB squared plus BC squared minus 2AB BC cos theta. Cos theta equals AB squared plus BC squared minus AC squared over 2AB BC. So cos theta equals AB squared, which is root 85 squared. It's 85 plus BC squared is also 85. AC squared is 98. 85 plus 85 minus 98 over 2 times the square root of 85 times the square root of 85. Theta therefore equals 64.94 degrees. We can apply the area rule to find the area of triangle ABC. So the area triangle ABC equals a half AB times BC sine theta. So that's going to be a half times root 85 times root 85 sine 64.94 degrees. The area of triangle ABC therefore equals approximately 38.5 units squared. We can also determine the area of triangle ABC by first dropping a perpendicular from B to AC, such that obviously BD is perpendicular to AC. Doing so divides triangle ABC to two congruent triangles ABD and BDC, and therefore D is the midpoint of AC. So we'll first determine the midpoint of D, rather the midpoint of AC, which is D, and that means D is the point minus 5 over 2 minus 1 over 2. Once we've got now that we have the coordinates of D, we can determine the length of BD using the distance formula. So BD is root 242 divided by 2, and then finally we can apply the area. We can determine the area of triangle ABC, which equals a half AC times BD, and that gives us the same answer of 38.5 square units. Triangle ABC has vertices at A minus 7, 8, B 3K, and C 8, 5. Given AB is twice BC, find the value of K. So again, we're just going to plot the points that we can. So AB equals twice BC. AB is the square root of 3 minus 7 squared, 3 plus 7 squared, plus K minus 8 all squared, and that equals twice the square root of 8 minus 3 all squared plus 5 minus K all squared. Now squaring both sides, let's first simplify what's underneath the square bracket. 3 plus 7 squared, that's going to be 10 squared is 100, plus K squared minus 16K plus 64. That equals 2 times the square root of 8 minus 3 all squared is 5 squared is 25, plus 25 minus 10K plus K squared. Now we square both sides to remove the square bracket, so we have K squared minus 16K plus 164 equals, we're going to square 2, so it's 4 times 50 minus 10K plus K squared. Now we can multiply it and simplify, so K squared minus 16K plus 164 equals 200 minus 40K plus 4K squared. Getting this into standard quadratic form, we have 3K squared minus 24K plus 36 equals 0. We can divide through by 3. K squared minus 8K plus 12 equals 0. K minus 2 times K minus 6 equals 0. K equals 2 or K equals 6. So B is therefore the point 32 or 36. You should obviously always check your work. So using the point B32 first, we can see that AB equals 2 root 34 and 2BC equals 2 root 34, so AB equals twice BC. And then if B is the point 36, AB equals 2 root 26 and twice BC also equals 2 root 26. So in both cases, AB is twice BC. Question 10. The line x plus y equals 4 meets the curve y equals 8 minus 5 over x at the points A and B. Find the coordinates of the midpoint of AB. Now, while it's not necessary to draw a sketch, it would be really useful if you do that. Again, it doesn't have to be 100% accurate. You just need to get an idea as to how to approach the problem. So we have y equals 8 minus 5 over x, which is obviously the hyperbola. And we have the line x plus y equals 4. In standard form, y equals minus x plus 4. Now even if we didn't have the diagram to work with, to find point of intersection, they said that the line x plus y equals 4 meets the curve at the points A and B. Therefore, A and B are the points of intersection of the two functions. So even without the sketch graph, when solving simultaneous equations, we isolate a variable and substitute that expression into the other function to solve for one variable, and then we solve for the second variable. So 8 minus 5 over x equals minus x plus 4. Multiply through by x. Obviously, x cannot be 0, as indicated by the asymptote, the y-axis. So 8x minus 5 equals minus x squared plus 4x. X squared plus 4x minus 5 equals 0. It'll factorize as x minus 1 times x plus 5, x equals 1, or x equals minus 5. Now, x equals 1 and x equals minus 5 represent the x coordinates of the points of intersection between the straight line and the hyperbola. To find the y coordinate, we substitute each x value into either equation. We're going to substitute into, it really makes no difference. You choose the easier equation. A straight line, y equals minus x plus 4, minus 1 plus 4 will be 3. So we'll have a point at 1, 3, which we'll call A, and then we do the same for x equals minus 5, so y equals minus 5 plus 4. It'll be 5 plus 4, so y equals 9. B is therefore the point, minus 5, 9. So there's our first point of intersection, A, 1, 3, and there's the second point of intersection, which is minus 5, 9. Now we are required to find the coordinates of the midpoint of AB. So the midpoint of AB will be x2 plus x1 over 2. So minus 5 plus 1 over 2. And then 9 plus 3. Y2 plus y1 over 2. 9 plus 3 over 2. So that'll give us minus 4 over 2 is minus 2. And then 12 over 2 is 6. So the midpoint, we'll call it M, of line segment AB is the point minus 2, 6. Line y equals x minus 3 means the curve y squared equals 4x at the points A and B. You're required to find the coordinates of the midpoint of AB and find the length of line segment AB. Okay, so to determine both the midpoint and the midpoint of AB and the line and the length of the line segment AB, we are going to need to know the coordinates of A and B. Now, A and B are clearly the points of intersection because the two functions, because they told us that the straight line meets the curve at the points A and B. So with or without the sketch graph, we are going to substitute y equals x minus 3 into the second function. So x minus 3 all squared equals 4x. X squared minus 6x plus 9 equals 4x. X squared minus 10x plus 9 equals 0. Factorizes as x minus 1 times x minus 9. So x equals 1 or x equals 9. X equals 1 and x equals 9 represents the x coordinates of the points of intersection of the two functions. Substituting into either equation to get y, we'll have y equals 1 minus 3 is minus 2. So the first point of intersection will be A, 1 minus 2. And doing likewise with x equals 9, we have y equals 9 minus 3, y equals 6. So B is the point, 9, 6. So the first point of the intersection will be 1 minus 2, and the second point of intersection will be B, 9, 6. Let's find the midpoint of AB. Midpoint of AB is x2 plus x1 over 2, so it's going to be 9 plus 1 over 2, and y2 plus y1 over 2, 6 minus 2 over 2, 10 over 2 is 5, and 4 over 2 is 2. So the midpoint M of line segment AB will have coordinates 5, 2. Then the length of AB is a straightforward application of the distance formula. So the square root of 9 minus 1 all squared plus 6 minus minus 2, 6 plus 2 all squared. That's the square root of 9 minus 1 is 8, 8 squared is 64, plus 6 plus 2 is 8, 8 squared is 64. So AB equals the square root of 128. In simplest form, that equals 8 root 2.